Okay, so I'm going to explain this with a video because it might be a bit easier. I'm not too sure how to do it with words that well. So let's go ahead and draw out our reactants and stuff. Alright, this, and then we've got this thing, CO2, CH3, and this thing right here, it's really just this dude that we've seen before, the NLA thing. And then we've got our OCH3, which is going to be OCH3 minus because the Na goes away. Alright, so what 1,4 addition means, it means that you've got an alkene here, and then you've got a ketone, or like a double bond O thing, right over here. And basically, it means that this dude is going to add onto the 4 position right over here, and that is 4 relative to this 1. So if we were to count our carbons, it's 1, 2, wait, my bad. Yeah, it should be the meta position. Yeah. So if this were like our first, then we'd have like 2, 3, 4. Kind of doesn't make too much sense now that I think about it, why it's called 1, 4. But all I need to know is that it adds to the meta position relative to your carboxy, relative to your O double bond. Okay, so just call it meta addition. Alright, so for this to work out, we've got like a hidden hydrogen here that this, our base is going to attack. And we're going to move up our curly arrows, and it's going to create, I think this is the enolate thing. O minus. And this thing right here is what's going to attack this meta position here and do our addition. Alright, so if we take a look at that, if we go ahead and write that out, we're going to have our double bond, our O here, this thing, the group. Then we're going to have our enolate right here, minus, let me just move that down a bit. Wait. Right, and this carbon right here is essentially going to attack this one right here. So 1, 4, attack the meta. So meta addition, 1, 4 addition. Alright? And then our electrons are going to move up. It's going to give us this thing. O minus, double bond here, and then attached is going to be this guy here. I'm not going to draw, well, I can just draw all of it, why not? This dude here, another way to write it is just the CO2CH3, CO2CH3. They are both the same thing. I'm just drawing it out because I feel like that's easier for me and I want to. Okay. Right. So, there we go. This is our 1, 4 addition. Now we're not really done here because what happens afterwards is that this oxygen here can eat a hydrogen, right? And then we'll produce this OH, which have our 2 groups here, blah 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 blah, and then it really just switches around to give us our product, which looks something like this. Which you can see up there in the answer key. But yeah, so again, just to recap, 1, 4 addition, our enolate gets protonated by our base, and then it becomes this kind of intermediate thing right here, and this carbon here goes to attack the meta position, or meta position, right here on our double bond. So it's our 1, 4 addition right there. And then it goes ahead, it attaches there, and from there on we get our product.